Hello everyone, welcome back to the brand new lectures in physics. So in the previous class we have discussed about the scientific process and the steps involved in a scientific process. So what are the steps involved in the scientific process? So the first one is observation, the second one is the preparation of the theory, third one is experimentation, and the fourth one is the modification. And we discussed about the types of observation too, that is subject to observation and object to observation. And then we had discussed something about the physical quantity, so which is the quantity used to prepare the laws of physics and which is used for the object observations. Okay, so in this class we are going to discuss something about the units. So in the formation of a unit or in taking anything as a unit, there are some standard reference rules responsible for that particular unit. So what are the standard reference rules and why they are required? For example, let us take an example of a kg, that is the unit of mass. For example, if that unit of mass changes from place to place and changes from time to time, will it be useful for us? Not at all. So that's why there are some prescribed rules to take a unit into consideration, and that is called as standard reference rules. So in standard reference rules, there are some things which we will discuss now. So the first one is invariance. So what is meant by invariance? So not varying from place to place as well as from time to time. So that means if you take a unit, it must be constant throughout the universe. For example, if you consider the gravitational force, the gravitational force on the moon is 1/6 the gravitational force on the earth. For example, if the gravitational force acting on an object here is 16 newtons, it will become 10 newtons on the earth. That itself means that the magnitude or the numerical value of force changes from place to place, but the unit, that is Newton, will not change. So this is the concept of invariance. So invariance in the sense it must not change from place to place as well as from time to time. So now the second one is accessibility. That means it must be easily accessible everywhere. If you want to use it, it must be readily useful for us. Okay, there may not be any separate processes, to use that particular unit. And the third one is precise, that is small. So the unit which you are selecting must be somewhat smaller, and it must have the ability to measure with some instruments easily. So underline this point. So you need to measure it easily. So that means it must be having some smaller quantity, not a bigger quantity which we cannot measure with the instruments that are available for us. So this is called as precise. And the fourth one is acceptability. That means that particular unit must be accepted throughout the universe. Then only it can be called as a unit. So here there are some types of physical quantities. So you all know it previously. I need to explain it in a short. So first and important thing is fundamental physical quantity. So what is meant by fundamental physical quantity? A quantity which is independent and cannot be dependent on other physical quantities is called as fundamental physical quantities. So example for the fundamental physical quantities are length, mass, time, etc. So that means they are having a separate instrument to measure them, and they are not independent of other physical quantities. So that is called as fundamental physical quantity. And the next one is the derived physical quantity. The name itself is derived from other physical quantities. So what is the example for that? Let us take an example of speed. So the speed can be easily measured using the value of distance as well as time. If you know the value of distance as well as time, then only you can calculate the value of speed. So that itself means that the speed is somewhat depending on distance as well as time. So it can be called as a derived physical quantity. So the example for the derived physical quantities are area, volume, speed, velocity, etc. So these are all the types of physical quantities. There is fundamental physical quantity as well as derived physical quantity. So now, I already said we need to frame some standard reference rules for the formation of a unit, right? So for that formation, there are some system of units also which are used to frame all these rules. So let us discuss them in detail now. So here are the system of units. So if you consider the system of units are broadly divided into 4 categories. So the starting was CGS system. Here if you observe, in CGS system, only 3 fundamental physical quantities are explained. That means they are considered actually. Only 3 fundamental physical quantities are considered. That is length, mass and time in terms of centimeter, gram and second. And the same will be applied in MKS system also. Here meter, kilogram, second. That means there are no fundamental physical quantity other than these 3 in MKS system. Okay. And the third one is foot, pound and second. Foot, pound and second. But here in the FPS system, if you observe, generally in these 2 systems, they have taken only the length, mass, time as the fundamental physical quantities, right? But here in FPS system, the value of pound is the unit for weight but not for the mass. It is generally a unit for weight. So it is the value of a body having a mass of nearly 0.4536 kg. That means the weight acquired by the 0.4536 kg of body is called as pound. Then what will be the unit of mass in this case? The unit of mass here is slug. S-L-U-G, slug. So this is the unit of mass in FPS system. So that was somewhat a different peculiar thing in this system. And the fourth and important system is International System of Unit, but it was derived as a SI, as a System International, which is derived from French. So here in SI system, they have just taken all the references. They have just taken all the references from the previous systems and they have just found 7 fundamental physical quantities. Previously there are only 3, right? Here length, mass and time only. But after that in SI system they have taken 7 fundamental physical quantities. They are length, which is measured in meters, mass, which is measured in kg, time, which is measured in seconds, and luminous intensity, which is measured in candela, temperature in Kelvin, amount of substance in moles, and electric current in amperes. So you have just listened about the temperature, amount of substance and electric current, but luminous intensity is somewhat different to you, right? So the word luminous intensity is the fundamental physical quantity which is used to calculate the brightness of a light. I think in olden days, in my childhood, I used to call a 40 candle bulb, 60 candle bulb and a 100 candle bulb. I used to call like that. But I understood the thing is, it is not a candle, it is candela. 40 candela bulb, 60 candela bulb and 100 candela bulb. So that means the candela itself will specify the amount of intensity of light. Intensity is nothing but brightness. Whereas the amount of substance is nothing but it is the mass of 6.023 into 10 power 23. That is Avogadro number. So which you are we will discuss in this concept of chemistry molarity. Okay. And the last one is electric current, which you already know. Okay, so the remaining physical quantities will be discussed according to the concept in that respective chapters. And in SI system, there are some supplementary units are also present, that is plane angle and solid angle. Plane angle and solid angle. Plane angle is, you already know, the angle between two lines is called as plane angle. Whereas if you consider the solid angle, it is the angle made by a solid surface. The angle made by the solid surface. So we will discuss the concept of solid angle in the next class. And once again, there is separate concept called dimensional analysis, which is the highlight of this particular measurement chapter. And we'll start that concept tomorrow. So hope you all understood the concept, today's concept. Okay, see you in the next class. Thank you.